Okay, good evening, students. I welcome you, and I always say that you have extraordinary intelligent students. The important point is to work hard, focus, concentrate, consistent, regular in your work. This is very important. That if you will work regularly and if you will listen to the lectures and do your homework regularly, students, and pay attention to each and every line which is written in the book, you can create wonders in this world. You can achieve anything in your life. That's what I say. So the basic fundamentals of success are always the same. Work hard, focus, concentrate, and do not waste your energy, students. Let anything happen, you continue to do your work. Doesn't matter pandemic or anything. You are studying, you are studying. As per the circumstances, we continue to hold online classes for the students so that they do not waste their time and learn as much as possible during this period of time. We are discussing with you students the structure of the atom. This is a very interesting story, and most important and amazing things are coming, student. That what we have been talking, students, structure of the atom, students, and the discovery of subatomic particles. We have already discussed the discovery of subatomic particles, the particles which make up the atom, the particles which are present inside the atom. So discovery of subatomic particles, we already told you, student, and you said ki, okay, the electron is discovered, then proton is discovered, and one more particle which is there, neutron, was discovered later on during the nuclear reaction. We will tell you about that also. So basically, the three fundamental particles are present inside the atom, students. And we have told you that electrons, this is negatively charged particles. Electrons were discovered by j.j.thomson, students, in the cathode rays, and the charge of the electron was determined as well as the mass of the electron is determined. These were discovered by Thomson. We are saying J.J. Thomson, student. And then canal rays were discovered, and we said there are protons. And James Chadwick discovered the neutron, student. So the three particles are there, the canal rays. We have already discussed this important particles which make up the atom. And as a scientist began working on the how these particles are present and where they are present inside the atom. So naturally they were giving their own nuclear models, students. What was interesting, the nuclear or atomic models. What I am saying, student, okay, I will put it this way. There, what were the scientists doing, students? After the discovery of these three particles, there was a need for atomic models. There was a need to give atomic models, students. And the atomic model should be such that whatever experiments we do, it should be able to explain it. And the time we get experimental evidences or experimental information which cannot be explained by a given model, that needs to be rejected and new models have to be formed. That is how the science progresses, students. Can you tell me first model was given by whom, student? Give me the information. You have done it. I give you 30 seconds. Question answer always in our every lecture so that we keep energy alive. What was the first model which was given? Name the scientist who gave the first model. Plum pudding model was given by whom? That Christmas plum pudding model was given first. Who was the person? Who was the scientist, student? Tell me. You know about it. Tell me, students. Name of.
Sir, J.J. Thomson.
Okay. So J.J. Thomson, who discovered the electron, student, he was the first to give a model which you call as a Christmas plum pudding model. in which he said there is a positively charge is distributed inside the atom and electrons are embedded into it. Is that right? Keep on interacting with me, student. But what were
Yes, sir.
the problems? And this model was then, this model failed, after the experiments were done by which scientist, students? Which experiment was done after which it was totally rejected? Name the scientist. Who was the scientist who performed an experiment, important experiment, after which this Thomson model is completely failed because it could not explain what it could not explain. Tell me. Name the scientist, student. Next model. Fast. We have always 30 seconds for question answer session, students. Keep on interacting with this, very important. Name the scientist. What was the, who said and what, how it failed? Tell me. Second model of the atom given by whom? You already know about it, students. Rutherford. Rutherford. What was the experiment which was done by Rutherford, student? Tell me. The experiment which was performed by Rutherford. What is that known as? What is the experiment which was done by Rutherford, student, which was responsible, we are saying, total failure of the Thomson model? What is the name of the experiment? Tell me. What was the name? Which experiment was done by Rutherford, students? Answer the question fast. Anya, what experiment was done by Rutherford? What was that? Alpha scattering experiment. Scattering of alpha particles by scattering of what particles? Alpha particles. Scattering of alpha particles by, ठीक है? Which foil? Gold foil. So he has used a very thin gold foil. The thickness could be about 100 atoms. And when he passed the alpha particles, the important result he obtained, the most of the alpha particle passed straight, which proved that most of the space inside the atom is empty. And then what happened? Few were deflected and 1 out of 12,000 rebound back, students. So what was the conclusion? After this, Rutherford, he has given his own model, student, Rutherford model of the atom. What is a Rutherford atomic model, students? Important, very, very important. The discovery of the nucleus is very important in the story of the atom, which we are using. That the entire positive charge and the mass, most of the mass of the atom is present inside the nucleus. Nucleus, students, this the center of the atom, which we are saying, is a nucleus, which has positively charged center in it, and also the most of the mass almost is present inside the nucleus. And then he said electrons revolve around the nucleus in circular paths, students, and the size of the nucleus, as was given by him after doing some calculations, is very, very small as compared to size of the atom. So this was born the Rutherford model atom. Yes or no? Tell me. Am I right? This information you know already, the Rutherford atomic model. And here we have shown you a picture of that, students, what is happening. We are saying this is our nucleus, students. This is the nucleus, as you can see, students, that this you can see, this is your nucleus. And inside the nucleus, student, what you are seeing, there are neutrons and protons, and the most of the mass, almost all the mass of the atom is present inside this nucleus. The mass of the electron is negligible as compared to neutron and proton. So you know, the proton is about 2000 times heavier than the electron, students. Mm, So most of the mass is present here. These are the electron students. He says they are orbiting. You can see they are orbiting, revolving around in circular paths around the nucleus. Electron orbits. That was the model which was given by the Rutherford. So you have neutrons, protons, and electrons. After the discovery of the nucleus, this was the best Rutherford could do. Okay. Now the question is this model correct or there is some problem with this model, students? So naturally, we are talking of what are the drawbacks. What are the drawbacks of student Rutherford model of the atom? What are the drawbacks of the Rutherford model of atom, students? One of the important problem which we are facing, students, that electrons are charged particles. What are electrons? They are charged particles. You are saying electrons are charged. Here you see that I have given you electron, proton, neutron, students, negatively charged, protons positively charged. No charge, mass of electron is negligible, 1 by 1800 times of the proton. And in terms of atomic mass unit, we are saying mass of the proton is 1 mu. The mass of neutron is almost equal to the mass of the proton, which is also 1 mu. Atomic mass unit, we already told you in the chapter of the atom what is 1 mu. And this negative charge, since it is negative, it will be attracted towards the positive charge. Proton will be attracted towards the negative charge because it is positive. So negative charge, it will be attracted towards the negative. Neutrons are neutral. They are not going to be attracted by either electrons or protons. And electrons are present outside the nucleus and present inside the nucleus. And also neutron is present inside the nucleus, students. Radius of the atom, you can see, is about 1 into 10 minus 10 meter. Then the radius of nucleus is 1 into 10 minus 14 meter. This is important point, student. The nucleus is very, very small. This is my nucleus. And you see, this is, you are saying, is a radius of the atom. Radius of the, my drawing is not that. I mean, I'm just saying that. If this is a radius of the atom, student, this is like a football field and this is the football in the center of the field. Hey, like a football, if you have seen a football field, inside the football field you are putting the football at the center of the field, it looks like this. So this is our nucleus and this is your atom, student, which is we are showing size or radius. This is the radius. So you can see that the size of the nucleus is very, very small, student, as compared to the radius. If assuming this is to be spherical in shape, student, then we are giving the size of the atom or the radius of the atom, radius of the atom, student, of the order of 10 minus 10 meter. And what is the radius of the nucleus? Radius of the nucleus 10 minus 14 meter. So you can see how small it is. That is said, most of the space inside the atom is empty. That is why the alpha particles pass straight. Only when they will strike this or pass near this, they will be deflected. That was the experiment which was done by Rutherford. If most of the space is empty, what is going to happen, student? These alpha particles were passing straight through them. Alpha particles, these are your alpha particles, stream of alpha particles. So empty space, empty space. But when they will come near to this, what will happen? That's where they will show deflection. And when it hits head on, then it rebounds back, student. That was 1 in 12,000. So this was a experiment which was done by the Rutherford, and discovery of nucleus is very important. Discovery of nucleus. So you are saying that all the mass almost and the positive charge, proton and neutron, they are present inside the nucleus. And it is very, very small, very, very dense, students. And rest of the space empty, electrons are orbiting around the nucleus. Okay, this was the model which was given by Rutherford, students. The problem which we were facing with the Rutherford. What was the main drawback, student? Drawbacks. What is the main drawbacks of Rutherford model. What is the problem with the Rutherford? As I said, the electron is a charged particle, students. Electron is a charged particles. What will happen if it is a charged particle? If electron is a charged particle, if it will revolve, if it is orbiting around the nucleus, what it will happen? Then it will undergo acceleration and charged particles. Students, we already know Maxwell discovery in physics. In physics, he said, if charged particles, students, if they are accelerated, what will happen if they are moving, student? Charged particles during acceleration, they will radiate energy. They will radiate energy, students. And what will be the result of this? You are saying this is your nucleus. If supposing electron is orbiting around the students, it will start radiating energy because it is a charged particle. What will happen if it loses energy? Radiation in the form of some light or emit some radiation, it will emit some light energy or radiation, some wavelengths of lights will be emitted. What will be the result of that, student? Thus electron energy is decreasing, it is radiating energy, finally it will fall inside the nucleus. In a very short period of time, this will collapse inside the nucleus. 10 minus 8 seconds or less than that, it will just go and fall inside the nucleus, student. That means if this is true, then the atom will be unstable. This is not stable. This model is not stable, student. This means this atom is unstable and will collapse. Will collapse, student. And if the atom collapses, then the matter also collapses. What matter we are talking about? You said all the matter is made up of atoms. But matter exists. Matter is not collapsing. And then if atom is not stable, matter cannot be there. Therefore, student, this model of the atom is unstable and therefore it cannot explain the matter which exists in the world which we live, students. And you won't be here, I won't be here if atom is not stable. And we told you how 70 kg man has billions and billions of atoms inside that, and these atoms are having subatomic particles, nucleus, and there is an electron, students. If this is a model, then we are all gone from this universe. Nothing is there, matter is not there. Therefore, students, the charged particles, when the electron is a charged particle, this is nucleus is a charged particle, it is orbiting, there will be acceleration. As it gets accelerated, it will radiate energy and lose energy. Radiation means it is giving energy, and finally in 10 minus 8 seconds or less than that, it is going to collapse inside the nucleus. This model is not acceptable, students. This is not a stable model. The atom is not stable according to the model given by Rutherford. Therefore, student, there was a need for some model to make this atom stable. Because we know atom is stable, we know the matter exists. If atom is not stable, matter cannot exist. So scientists were performing large experiments, students. And in this connection, it is important that the greatest work which came forward in 1885 to 1962, students, was done by Bohr scientist. And today everyone knows about Bohr's model of atom, very important, students. Bohr's model of atom. What Bohr was doing? Bohr was performing, students, some experiment on spectra, atomic constitution, atomic theory, and description of the nature. Actually, experiments were done on light also. Light is an electromagnetic radiation, students. Experiments were being done on the light, nature of light also at that time. And they were studying the spectra of hydrogen atom and other elements also, what we call as atomic spectra. So Bohr was performing experiments on that, and he, in order to overcome students the drawbacks of Rutherford, Bohr proposed Bohr proposed certain postulates, which is called the model of the atom. So what is that story, student? I hope you understand. In order to we are saying, overcome this main problem which you are seeing, in order to overcome the drawback or problem with the Rutherford model, Bohr proposed certain postulates which are called Bohr's postulates. Bohr's postulates or Bohr's model of the atom. So Bohr gave certain postulates, or what we call as Bohr's model of the atom. Now he says that electrons are revolving around the nucleus. No problem about this. That is correct. But if electron is revolving in fixed orbit or in fixed shell, I say, or in a fixed energy level, it will not emit students the radiations, because if it will emit the radiations in a definite orbit, then it will lose its path and finally fall inside the nucleus. So therefore the radiation of energy is not taking place when electrons are revolving in orbits, and there are definite and discrete orbits in which the electrons are revolving. Therefore, what I am trying to say, student, what the Bohr proposed, as I said, he was doing large number of experiments on spectra, atomic constitution, atomic theory, and description of nature. Students, lot of scientists were working on these, and the atomic spectra of hydrogen was studied. There was a lot of experimental information available before the scientists, and in order to overcome the drawbacks or the objections in the Rutherford model of atom, Bohr has proposed very, very important things. Here I have two important points about Bohr, student. This is important for your exam. You must know them, must learn them. Bohr is saying, first, only certain special orbits known as discrete orbits of electrons are allowed inside the atom. What we are saying, you are saying that nucleus is discovered. No problem, nucleus exists. Now the electrons are not everywhere, he says, but they are moving in certain discrete orbits. These are the orbits. These are first orbit, supposing this is the first orbit. Here I am saying the electron is moving, and then there are more such orbits, student, more such shells or orbits where the electrons are moving. There are more orbits like this, students. We are saying there are orbits. Bohr is saying that there are orbits, students, in which there are electrons are moving outside the nucleus. These are nucleus, electrons are orbiting around the nucleus, but this there only electron is here but not here. Electron is here, not here. There are definite special orbits. We are saying there are special, he said there are special orbits which we are calling as shells or energy levels. Energy levels, students, which are allowed. Allowed means electron can be here, it cannot be here. I am saying there are only allowed definite orbits for the electrons. For so many electrons are there in an atom. We will see. For if I take hydrogen, you are saying hydrogen has 1 electron, carbon has 6 electron. Atomic number of carbon is 6, which will be discussed in the atom. We have told you the number of electron is equal to the atomic number of the element. So the number of electron, as atomic number increases, the number of electron is increasing, and number of protons and neutron is also increasing. We are going to discuss mass number, atomic number also in this part of the study of the atom structure. So what we Bohr said that there are all the orbits are not allowed for the electron. Only certain definite special orbits, which I am calling as shells or energy levels, are allowed. Why would we say that? Because there were experimental results available before him while he was studying the spectra of the hydrogen atom students. Atomic spectra and all these experiments were also done by many scientists who are studying this. So what we are saying, students, that not all the orbits are allowed, only specific and definite orbits are allowed in which electrons will revolve. And so long as electron revolves in this orbit, it will not radiate energy, because if it radiates energy, it will fall inside the nucleus. So this is important point number two. First, only certain special orbits known as discrete orbits of electrons are allowed inside the atom. Inside the atom. Second, while revolving in discrete orbits, electrons do not radiate energy. These two points are very important, students, which were proposed as postulates by Bohr in order to overcome, student, the drawbacks which are there in Rutherford model of the atom. Is it clear to you, students? Tell me, any doubt here? Do you have any
No,
doubt?
sir.
Because if certain special orbits are allowed and they are not going to radiate energy so long as they are moving in this fixed orbit, I call it energy level. I call it shell. First shell, second shell, third. And there will be so many shells. How many electrons can be there in every shell? That also we are going to give you a formula. All this is a what we call as Bohr's postulates. Bohr scientist proposed this because we know atom is stable, and if atom is not stable, then matter will not exist, and atom will also not exist. Therefore, we have to overcome the drawbacks of the Rutherford. And Bohr, as we have shown the picture of Bohr also, he was awarded Nobel Prize for his work in 1922. So he has written many books also. So this is the beginning of the structure of the atom, because in chemistry, what will help us, we should be able to know where the electrons are present inside the atom, how many are present, and in which shell the electrons are present. In the shell, there will be subshells also, students, which are not mentioned in the ninth class book, but I will tell you. So on that basis, we will be able to find the combining capacity of the element, because in chemistry, what we are doing, these atoms don't exist as atoms, they combine to form molecules, they combine to form compounds. How will the atoms combine and form molecules and compounds? Where the oxygen atom is not there in the atmosphere, student, it is dioxygen. Dioxygen is a gas which is existing in the atmosphere. Dinitrogen is a gas which is there in the air. It is not a nitrogen atom, it is N2, students. When I say O2, O2 means there are two oxygen atoms, they are combined to form O2. So how do we explain all this? If we can write the electronic configuration of elements, students, then we will be able to find out the valency of the atoms, combining capacity of the atoms, and will be able to understand the formation of molecules, various compounds which are existing in nature. How H2O is formed, water. What is water? Dihydrogen oxygen, carbon dioxide. All this, how do we explain? They are not atoms, but atoms have combined. Why the atoms are combining? All this is a story which can be answered if we understand the structure of the atom, and from this we can write the electronic configuration. That is why this model is very important for us, students. Okay, now what I have tried to tell you, students. Here is a picture of the Bohr's postulate. Very important, student, very important. Bohr's postulates are very important. Bohr's model of atom. Bohr's model of student atom. There, I also say postulates. These are the postulates of Bohr. It was supported by experimental results as he was studying the atomic spectra of hydrogen and many scientists. As I say, there are a lot of experiments have to be done. Experimental evidence is a must for any science postulate or for any model. And when more experiments are done, more information is available, which cannot be explained by this model. We have to go for another improved, modified model, which can be proposed by other scientists. That is how everything happens in science, students. The important two things I told you in this. You are saying electrons revolve around the nucleus in definite energy levels called orbits or shells. Here I have shown a picture of this, student. This is my nucleus. In case of any doubt, student, you can call me. What is this, student? Nucleus. Okay? You have a nucleus, students. I marked it red. What the nucleus contains? Neutrons and protons. Okay? In the nucleus, tell me what particles are present inside the nucleus, student. Jaldi, 30 seconds. Name the particles present in the nucleus. Tell me, Vidhi, which particles are present inside the nucleus? You have neutrons and protons. We represent N and P. They are present inside the nucleus. If I say that this is the nucleus, students, this will have N and P, neutrons and protons. Different elements have different number of neutrons and protons, which we will see as we proceed further. So inside the nucleus, you are saying there will be two particles, every nucleus. Hydrogen has no neutron, only one proton. We will see that. So after this, you are saying electrons will revolve around nucleus in definite energy levels. You can see that here we have drawn, Bohr has drawn. These are the energy levels, student. This is, I am giving the value, and when n is equal to 1, this is my first energy level. This is called K shell. What do we call it? K shell. Their names have been given English letters K, L, M, N, O, and so on. So first one is K shell. This is the lowest energy level you can see. These are called orbits or shells. We call them as, these are called orbits or shells, or they are called energy levels. So n equal to 1 is a K shell, first energy level. First energy, why I talk of energy? Because they are associated with energy level. Second one, I am saying n equal to 2, student. What is the name of that? Tell me what I have written here. Nucleus, first, this is my first one. This is number 1, n equal to 1, K. This is n equal to 2, L. N equal to 3, student. What is the name of n equal to 3? L shell. This is my L shell, students. N equal to 2 is L shell. This is my second energy level. And then here, what is n equal to 3? What is n equal to 3? Tell me. M shell. This is my third energy level. There will be, how many electrons will be there in the shell, that also we will tell you. Next I am coming n equal to 4, students. Where is n equal to 4? This one. Okay? If n is equal to 4, which is it called n shell. Fourth energy level. And there can be more as you go. So I can draw more, n equal to 5, n equal to c, and so on. As you are going student from here nucleus to this, the energy is increasing. Energy level, why do I call energy level? There is an increase in energy. There is an increase in energy. The electrons will be filled in these shells inside the atom. Electrons are present where? You are saying electrons are present in these shells. How many? That we will tell you. There is a formula which was given and proposed. So there are electrons in the K shell, there are electrons in the L, M, and depending on how many electrons are present in an atom, students. And so long as electron is orbiting around this, it does not lose energy. Because if it loses energy, then it will fall inside the nucleus. And this energy, this electron is moving, but it is not radiating any energy, it is not losing energy. And similarly, when electrons are orbiting around this, they are not losing energy, they are not radiating energy. When electron is moving in the third, not radiating any energy, moving in fourth, it is not radiating any energy. Is it clear? First you tell me, up to now, is it clear? Tell me students, have you understood
Yes,
what are
sir.
shells or orbits? Or orbits? Students, have you understood this idea of shells or orbits?
Yes,
These are also called energy levels. Levels of different energy, lower energy, higher energy, higher energy, higher energy. As the electrons are moving away from the nucleus, their energy is increasing. Energy is increasing, students. So here I have told you there is a K shell, L shell, M shell, N shell, and so on. That means N value, this is a first shell, 1. N value 2, N value 3, N value 4, and so on. ठीक है? And what is N? N is a first shell, second shell, number of the shell which is present inside the atom. But the shell contains electrons. How many? That I will tell you just now. So there are electrons which are present in the shell. They are orbiting around the nucleus. So long as they are orbiting in special fixed orbits, there is no radiation absorbed or emitted. But electron can absorb energy and jump from lower to higher energy level. Electron can absorb energy, students, and jump from lower to higher energy level. Similarly, electron can fall from higher to lower energy level and emit radiation or energy. That is possible. In other higher classes, this is ninth class physics science, so we are not talking about that here. But I'm just telling you that electrons can absorb, the atom can absorb energy. And when it will does it, then electron will jump from lower to higher energy. Similarly, atoms can emit radiation or energy when electrons will fall from higher energy to lower energy. So here is the story, the postulates of the Bohr, which we are talking, that there are orbits, there are shells, and we have given names to them, students, K, L, M, N, and there are electrons in these shells which are orbiting. So long as electron orbit in K shell, it is not radiating or losing energy. Similarly, electron of L shell is not radiating or losing energy. They are orbiting in fixed orbits. This is a proposal and model of the Bohr, students. So I will proceed further. On the basis of Thomson model, explain how the atom is neutral. That you already know that the positive charge is must be equal to the negative charge, so it will become neutral. On the basis of the Rutherford model of atom, which subatomic present particle is present in the nucleus of the atom? What? Tell me what is the answer of the question number 2, students? On the basis of Rutherford model of atom, Rutherford, which particle is present in the nucleus of the atom according to Rutherford? Proton, positively charged particles. Draw a sketch of the Bohr's model in an atom with 3 shells. So you can draw this 3 shells. Nucleus, You have how many shells? He is saying three shell. First, I'm putting another one student. My drawing is not that good, and I'm saying the third shell. ठीक है? How many shells? Exact picture is given. This is my K L M. N equal to 1, 2, and 3. ठीक है? What do you think would happen? Observation if alpha particle scattering experiment is carried out using a foil of metal other than gold. What will happen? This you can see that if gold foil they have used with very thickness is very small because of the 100 atoms, and the alpha particles are also heavy in mass. They were scattered. So if you will use some other metal, what will happen? You may not be able to experience that scattering experiment because the thickness is important. The 100 atom thickness they could obtain with the gold metal because it is some very malleable metal. So this is just a exercise of the brain, students. Okay. So right now, students, what we have been able to give you, we have shown you that there is a Bohr's atomic model. Bohr's atomic model was given, and we have listed two important points and shown you that. Now, in neutrons, we said that you discovered electron, j.j.Thomson, and we have given you the experiment also in discharge tube when he discovered cathode rays were moving from cathode towards the anode side. Students, charge of the electron was determined, mass of the electron was determined. We have already explained to you, and then you have seen that canal rays, after the canal rays were discovered, then Goldsmith, you have seen the charge and mass of the proton was also determined. And neutron are neutral particles. They were discovered in 1932, student, much later, 1932, by James Chadwick. They were discovered by James Chadwick. This particle had no charge. This particle had no charge, student. This was neutral and mass nearly equal to proton. Mass nearly equal to proton. They are present inside the nucleus of the atom. Present inside the nucleus of the atom. Nucleus of the atom. And is represented by N. N means neutron, and therefore mass of the atom, if I say what is the mass of any atom, it is what mass of proton plus mass of neutron plus mass of electron, but mass of electron is negligible, since I can say that is equal to mass of proton plus mass of the neutron. I can write because mass of electron is negligible. Mass of electron is negligible, student. We have already shown you. The mass of electron is 1 by 2, about 1 by 2000 or 1 by 8 by 1848 times that of the proton or neutron. So proton and neutrons are about 2000 times heavier than the electron. So we can assume that this is negligible mass, very small. And we can consider mass of the atom to be the mass of proton plus mass of neutron. So that means the entire mass of the atom is present. Where, students? Where is the mass present then? Because electrons are outside the nucleus. Tell me, where is the atomic mass present? Where is the atomic mass present, student? Where is the atomic mass present? In the nucleus. So you are saying the mass of the atom, student, is equal to mass of proton plus mass of neutron. That's what we are saying. Mass of atom is equal to mass of proton plus mass of neutron. The mass of electron is negligible. For example, student, I say that the helium atom, student, helium atom has atomic mass equal to 4 units. Equal to 4 units. For you know what is U? Atomic mass unit we have discussed in the chapter of atom. 6.7 10 minus 24 gram. We gave you the value also. 1 unit, one atomic mass was equal to what? And we are saying helium atom has got 2 protons. There are 2 protons in helium atom. ठीक है? Now the question is find the number of neutrons. Find the number of neutrons, student, in helium atom. Tell me how many neutrons will be there in the helium atom. I give you 1 minute. Answer the question. Answer the question, student. How many neutrons will be there in the helium? Protons are 2. Mass is 4u. Tell me how many neutrons will be there. Answer the question. You have 30 seconds. You have 30 seconds to answer the question, students. What is the, I've already written mass of proton.
So 2 neutrons.
Okay, correct answer given by Nidhi. You are saying P plus N is 4. And how many? 2 plus N is 4. Then N will be how much? 4 minus 2. So helium has got 2 protons. The nucleus of the helium has 2 protons and 2 neutrons. That's what we are saying. That inside the helium, student, helium, you will write like this. This is the atomic number of the helium. Helium has got 2 protons and 2 neutrons, student. The nucleus of the helium will have 2 protons and 2 neutrons. And number of electrons will also be 2 because the number of charge has to be neutral. So we will say that there will be electrons. How many? 2. So 2 protons, 2 neutrons and 2 electrons are present inside a helium atom, students. The charge of proton is positive, 2 positive and 2 negative. So the atom becomes neutral. This is how we can work out. More questions are coming on this after we finish this topic. So we are now aware that there are 3 particles which are inside the atom, and inside the nucleus there are 2 particles, protons and neutrons. The entire mass is due to the nucleus. The mass of electron is negligible, but if we add up, we can calculate the value. Now the question is how the electrons are distributed in different orbit or shell. You are saying there are electrons in the shell. How they are present? How they are distributed? How many electrons will be there in K? How many electrons in L, M, and so on? So we are saying atom of an element is most stable when it has minimum energy. Everything wants to be stable, student, stable. Atom, we want atom to be stable. You want that atom should be stable. And scientists know that if it has to be stable, the energy should be minimum. Anything which is stable has lower energy, lower energy. Energy increases, the stability decreases. If there is more energy, then that particle will be less stable. So how will we make energy least, or how will we make energy minimum? More stability means, student, minimum energy should be there. Minimum energy. Therefore, whatever electrons we are filling inside the atom, they are going into different energy levels. K, L, M, and energy is increasing. So lower energy means first the electron should go to lower energy to be stable. And if there are more electrons, they will go to higher energies. Different elements have different number of electrons. So the first thing is the electron will first enter into the lowest energy because that is the most stable state. After that, if more electrons are there, they will go to the next shell, next, and like this. So students, what we are saying, important point, atom of an element is most stable when it has minimum energy. An atom will first fill the lowest energy level. First, the atom will go to the K. K is the lowest energy level, N equal to 1. and after it is filled, it will go to the next level. If in a building student, there are many floors. The first floor is ground floor, first, second, third. You have to apply less energy to enter first. For second, you have to climb the stairs. More stairs, third floor. So naturally, ground state will be the first to be occupied. And then you go to higher, more energy. As you are going rising up the building, more energy is required. More energy is required to climb from ground to first, second, third, and so on. So the least energy is that most stable state is the ground. Similarly, in atom also we are saying first they will go to which K shell first. So you are saying this is a nucleus. Which is the first one? K. And the next one? L. Students, and so on. These are the shells L, M, and so on. So these are ground state K. K is your ground state, student. And this has a minimum energy. Minimum energy. Minimum energy. So the first electron will fill where? In the K shell. So the filling will take place how? The filling of electrons, students, in the atom, they will go from K to L to N and so on. So first electrons will enter K. After it is filled, they will go to L. After it is filled, they will go to M. After it is filled, they will go to N. Right or wrong? Tell me. Okay? Because the minimum energy requirement can be achieved by this method. More stability means minimum energy. Minimum energy is required for more stability. Therefore, students, there are rules which were given. There are rules which have been given for the filling of the electrons. Student, rules for filling of the electrons have been given. We are saying rule 1, maximum number of electrons present in a particular shell is calculated by the formula 2n square. K shell, student. We are saying maximum number of electron which can be kept in any shell is given by maximum number of electrons, students, is given by formula 2n square. 2n square rule. What is n? First shell K shell. For example, what is the maximum number of electron in K shell? What is the value of n for K shell, student? K means the first shell. The first shell, student, n equal to 1. So what is the maximum electrons, students, in K shell? Formula is 2n square. What is the answer coming? 2. So only 2 electrons can be there in the first shell. L shell. What is the value of n for L shell, student? Second shell, 2. What is the maximum number of electrons for L shell? Maximum number of electrons, student, in L shell will be what? 2n square, formula 2 the square. What will be that? Tell me how much it is coming? How much it will be value? M shell, n equal to 3. What will be the maximum electrons? Maximum electrons in this 2, 3 the square, student. What will be 2 the square? 4, 8. How much it is coming? 3 the square, 9 into 2, 18. And for L shell, students, n is equal to 4. What will be the maximum number of electrons? Tell me, students, what is your answer? What is your answer? For n equal to 4, how many electrons will be there? Maximum. Tell me, what is the value coming, students? What is the answer, Anya? N equal to 4. How much will be this value? Tell me, what is the answer coming? This is the formula which can calculate the maximum number of electrons that a shell or orbit can accommodate. What is 2n square in this case? 2 into 4 the square, how much is that? 32. So by this method, students, we can calculate maximum number of electrons that a particular orbit or shell can accommodate. Maximum number of electrons a shell can accommodate, student, can be calculated by the formula 2n square. Got it? What is this formula? 2n square. By using this, we can calculate maximum number of electrons, that an orbit can accommodate. Any doubts, students, here? Tell me, do you have any doubts? Any doubt?
No, sir, no doubt.
So K shell will have 2 electron maximum, L shell will have 8, M will have 18, and L shell will have maximum of 32 electrons. This is our rule number 1. What is this? Rule 1. On the basis of the Bohr's atomic theory, Bohr's model of the atom, rule 1 says this is the maximum number of electrons. We can use the formula 2n square. Second rule says the maximum capacity to hold electron in the outermost shell is 8. Now the story is like this, student. Rule 2 is important. Rule 2 is important, not clear from the NCERT book, but I will tell you rule 2. It says here you can say there are 18 electrons maximum 18 electrons are possible, but he is saying maximum capacity to hold electrons in outermost shell is 8. What do you mean by this? Maximum capacity to hold electrons in outermost shell, in outermost shell I am saying is 8. What it means, students? Rule number 2. That means though the total number of electrons can be 18, but maximum is 8. Actually, what we want to say, there are subshells within the shells. What I am trying to say, there are subshells in the shells. In the shells. Students, this concept is not shown in the 9th class book. Later on, we will see there are subshells within the shells. So when we will distribute 18 electrons, they will go into subshells. देखिए, you are entering into a house, ground floor house. There are different rooms in the house. And there are different rooms in the house, students. So there are subshells in the house. Subshells. Your house is a shell. Inside that there are subshells. And then in each subshell, you have supposing bedrooms, drawing rooms. So in supposing one bedroom, you have a double bed. In one, you have a single bed. So different people can sleep in different rooms. Different number of persons can sleep in different rooms, depending on how many beds you are putting. So there are shells, and within the shell, there are subshells also. So electrons live where? Electrons go into a shell, and in the shell, they go into subshells. And subshells have got orbitals. These subshells have got orbitals, and in each orbital, maximum of 2 electrons can live. So we are saying there are subshells. There are shells, students, which we are writing K, L, M, N. That depends on the value of N, 1, 2, 3. N is equal to 1, 2, 3, 4. And then I'm saying in these shells, students, there are subshells which are represented by S, P, D, F. There are subshells which are present in these shells, which are represented by S, P, D, F. This we will learn in a higher class. And in these subshells, there are orbitals, students, orbitals in which electrons live are filled, in which electrons are filled. That is why he is saying the maximum capacity to hold electron in the outermost shell is 8. Because otherwise you are saying 32, but when you will see the electronic configuration, you will find that maximum is 8. We will explain more about this in the next lecture. The electrons will fill the inner shells before outer shells. As I said, lower energy state is more stable, so first electrons will enter the lower energy, then they will go to higher energy. The first shell to be filled will be K. After 2 electrons, K can have maximum of 2 electrons. After 2 electrons, the third will go to L, and after total 8, 10, 2 plus 8, 10 electrons are filled, then the next will go to M, because this is completely filled. This is completely filled, then next shell. This is filled, then next shell. This is filled, then next, like this. And in this way, students, we are able to write the electronic configuration of the elements. Different elements have different atomic numbers, different number of electrons. Therefore, we will try to write their electronic configuration, means distribution of electrons in different shells. And shells have got subshells. Subshells have got orbitals. This is how we write the distribution of electrons in an atom. For our ninth class, this Bohr's theory is sufficient up to rule 1, rule 2, and rule 3. So I hope you have understood and noted the students. Any doubt?
No, sir, no doubt.
Okay, then we'll continue more about this in our next lecture, students. And bye bye. Wish you all the best. We'll meet you in the next class.
Thank you, sir.
Okay.